Dear students, I am Nilanjana Sanyal. Welcome you all to my channel NS Online Math Classes. Our today's topic is inflation. This is the second video on this topic, inflation. In our previous video, we have seen how to get the indexed value of an object for inflation over a period of time. And in our today's session, we will be learning about the real value of an investment. So first of all, we have to know what do we mean by this term real value of an investment. So let's start with our today's session. The real value of an investment. Now, to understand how well an investment will be performing, suppose we keep money in banks and the banks give us some compound interest, which is compounded half yearly, monthly, quarterly, annually, and we get some compound interest and we get back an amount after say 5 years, 10 years, depending on how much time we are keeping that money in that bank. But the money that we will be receiving after that many years, we do not know what will be the purchasing power of that money at that point of time. When we invest something, when we keep some money in a bank, we know what we are keeping, we know that money's purchasing power. That is today's value of the money. We know that. But we do not know what will the future value be. The amount that we will be getting after 4 years, 5 years, we may calculate that the bank is offering this much rate of compound interest, which is getting compounded, say, half yearly. Then how much will we be getting back after 5 years? That is simple mathematics. But what we do not realize is that the amount that we see or we calculate, that amount's purchasing power will not be the same as today's money's purchasing power because of inflation. Therefore, if we have several schemes and we have to decide where should we be investing our money, we have to know which scheme is most profitable for us. Therefore, we have to know what is the real value of the amount that we will be getting after say maturity, after say 5 years. And how do we get? And that real value is known as the real value of the investment, which takes into account the inflation factor, because the compound interest calculation will be giving us the money that we will be receiving after say 5 years, but that money's purchasing power is not taken into account. It may happen that we see that, oh, we are investing say 5,000 and we are getting back 6,000 or say 7,000, whatever is the rate. So investing 5,000 and within say 3 years we are getting back $7,000. So it is very good. But is the 7,000 equal to 7,000? Because when we are reading this term $7,000, we have this in mind that $7,000, with the $7,000 I can purchase these things. And what are these things? These things are the same, definitely, but how are we deciding we may purchase these things? We are assuming that the present prices of those things. But after say 3 years, the prices will not be remaining the same. They will be increasing. Okay, So we have to understand that $7,000 that we are thinking that we will be getting after 3 years will not be exactly $7,000 because its purchasing power will not be equal to $7,000. So we have to know its real value. And how do we know its real value? We have to know what will its value be in terms of today's purchasing power, because we know what is the today's purchasing power. We know that with $5,000, how many things we can purchase today. That is known to us. Therefore, we have to know that $7,000 that we will be receiving after 3 years, what is its real value? What is its today's purchasing power? Only then can we decide that whether that scheme is profitable and how much profitable it is to us. Okay? So how do we find that, the real value of the investment? We have seen that to index a value for inflation, we multiply its value by the inflation multiplier each year. Suppose an object costs, say, $100 and the inflation rate is, say, 3% per year, and we have to index this value, say, over 4 years. How do we get the indexed value? That is 100, the present value, times 1 plus this inflation rate, 3/100, to the power of 4. That is, since the number of years is 4, this is the multiplier. Inflation multiplier is this 1 plus 3/100, and this is getting multiplied for every 4 years. To the power of 4 means 1 plus 3/100 times 1 plus 3/100 times 1 plus 3/100 times 1 plus 3/100. Okay? So for every year you are having this multiplier, one multiplier for every year. So this is known as the inflation multiplier. So in order to index a value for inflation, we multiply the present value of the object by the inflation multiplier for each year. So to get the real value, the final value of the investment in today's dollar, or the real value of the investment, we will be doing just the opposite. We will be dividing its value, the same inflation multiplier, for each year. Okay? So this is what we will be doing, and you will be understanding this better if we take up few questions. Okay? So without any further delay, let us move on to the questions. First question says, Brooke invested $4,000 in an account that pays 3% per annum interest rate, compounded half yearly for 6 years. First, subpart A says calculate the final value of the investment. We know how to calculate the compound interest amount, so we start with our answer. So the amount will be equal to principal. The principal is 4,000 and 1 plus, now this is 3% per annum and it is compounded half yearly. So what will be the half yearly rate of interest? It will be 3/2 or 1.5. So I am writing 1.5/100 And how many half years are there in 6 years? 12. So raised to the power of 12. Okay. So what is this value equal? It will be 4000 times 1 plus 1.5 divided by 100 to the power of 12. That is 4782.47. $4782.47. $4782.47. This is the amount that Brooke will be getting back after 6 years when he has invested $4,000 in an account which pays 3% per annum interest and it is compounded half yearly. Okay. So this is our answer to the first subpart. $4,782.47. Okay. This is our answer for the first subpart. And next we move on to the next subpart. That is subpart B. Given that inflation averaged 3.2% per year over the investment period, find the real value of the investment. So, real value of the investment will be is equal to 4782. I'm not writing the dollars part. If you want, I may write it. Yes, actually, you should be writing it, but while I'm doing the calculation, I am not writing the dollar, but okay, I have written the dollars. Okay, so this divided by 1 plus inflation rate is 3.2% per year. And the time is 6 years. For each year, you have to take this inflation multiplier. So, what is this equal to? Let me take the answer. Answer divided by 1 plus 3.2 divided by 100 to the power of 6. 3958.90 I can take. 3958.90. 3958.90. Okay, 0.90. Let me write it over here again. This is $3958.90. Okay, and I write it over here again as the answer for the subpart B. $3958.90. This is the real value of the investment. That is, this is the money that we will be getting back. We will be getting back, no doubt, this money. But its purchasing power will be this. After 6 years, the purchasing power of this money will be equal to this. So, subpart C, discuss the effectiveness of the investment once inflation has been considered. Not at all effective, because we are investing $4,000 and the purchasing power of this $4,000 is $4,000. Today's purchasing power. We are investing now, so it is the today's purchasing power. And it is $4,000. And after 6 years, we will be getting an amount whose purchasing power will be less than what we are investing. It is $3,958.90. We will be getting an amount which is definitely more than $4,000. But this amount's purchasing power will be less than what we are investing, that money's purchasing power. So definitely it is not an effective investment. Not an effective investment. I am not writing the reason because I don't have sufficient space, but I have given you the reason. You have to write that, because the $4,782.47 purchasing power will be equal to today, in today's dollars, it is equal to, or purchasing power is equal to $3,958.90, which is less than the amount that we are investing. So definitely not an effective investment. Okay. So this was our first question. Let us move on to the second question. Jerome placed $6,000 in an investment account. The account pays 0.5% interest per month, and the inflation is 0.1% per month. Usually we see the inflation rate is given per year, but this has been given in per month. The subpart A says, explain why the real interest rate is approximately 0.4% per month. And the subpart B says, hence find the real value of the investment after 2 years. So let's start with our answer. Subpart A. Explain why real interest rate is approximately 0.4% per month. What is the interest rate per month? 0.5%. So what will be the multiplier? For the amount, it will be principal, that is 6,000 times 1 plus 0.5 over 100. Per month, the money $6,000 will be increasing by this multiplier, right? So this is the multiplier. Now, what is this? After 1 month, the money that we will be getting, that is also under the effect of inflation. So we have to get the real investment, real value of the investment for that money also. And what is the inflation rate? It is 0.1%. So we have to divide by 1 plus 0.1 over 100. So what is this equal to? 1 plus 0.5 divided by 100. This is getting divided by 1 plus 0.1 divided by 100. What is this equal to? 1.003996. 1.003996. This is equal to 1 plus 0.3996 over 100. And this part is the rate of interest, which is roughly equal to 0.4. Now, if this way is slightly difficult for you to understand, let me just get the value or the amount of the $6,000 that has been invested after 1 month. So what will be the amount after 1 month? Only 1 month I am taking, that will be sufficient. So principal is 6,000 and it is 1 plus 0.5. This is the monthly interest rate they have given. So I do not have to do any modification. 1 plus 0.5 over 100 and it is for 1 month, so it is 1. What is this equal to? 6,000 times 1 plus 0.5 over 100, and it is for 1 month, so I do not have to just take it to the power of 1. This is equal to 6030. Okay. So after 1 month, the $6,000 that we have invested becomes $6030. Okay. Now, this is not the actual value that we will be receiving. What is the real value? What is its purchasing power? Because after 1 month, the inflation will be, this money's purchasing power will be different because of inflation. Okay. So what is the purchasing power of this money? The real value of this money? That will be given by, if we divide this 6030 by the inflation multiplier, that is 1 plus 0.1 over 100. It is for 1 month, so, and the inflation rate is also given for 1 month. So we do not have to do any modification, and let us see what value do we get. 6030 divided by 1 plus 0.1 over 100. Okay. So what is this equal to? 6023 point, I can take 98. Okay. 6023.98. 6023.98. So the real value in today's purchasing power, real value of this $6,000 after 1 month is $6023.98. Up to this point, clear? So now let us see that this is the amount. This is the real value of the investment. So I'll be taking this to be the amount and this to be the principal, and I will be getting the rate for 1 month. Okay. So in place of amount, I am writing 6023.98. In place of principal, I am writing 6,000. We do 1 plus, we do not know the rate. We have to find the rate. So it is R over 100. And it is for 1 month, so 1. Okay. So what will be R equal to? R will be equal to, okay, let me take first of all R over 100. R over 100 is equal to 6023.98 over 6000 minus 1. Okay, so, and this can be multiplied with 100. I had kept R over 100 because if I read this whole thing in one step, it may be difficult for you to understand. So now I will be just erasing this part. So R value is equal to 6023.98 over 6000 minus 1 times 100. Okay. What is that equal to? So I take answer divided by, first of all, let me take this, put the parenthesis, okay. And this is getting divided by 6000. Okay, so, and not yet over, so it is not, yeah, minus 1. And now we have to close the parenthesis and multiply by 100. Let us see what we get. It is R equal to 0.3996, almost equal to 0.4. Okay, so this is almost equal to 0.4%, obviously. That is the same thing that we had got, and that is what they are saying, explain why real interest rate is approximately equal to 0.4% per month. If you find this method slightly difficult for you to understand, you may apply this method. Okay, I have shown you if the principal is 6000 and it is having 0.5% compound interest per month. I have found the value that we will be receiving after 1 month, or Jerome will be receiving after 1 month. That is $6030, and what is the real value of this? It is $6023.98. Okay, now we are just forgetting the effect of inflation and we are assuming that there is no inflation and we are getting $6023.98 after 1 month, and we have invested 6000. So what is the rate of interest? This is amount, this is principal, the month is 1, and we have to get the rate of interest per month. So we have to get the R value, and we have found it is almost equal to 0.4% per month. Clear? Now we come to, hence find the real value of the investment after 2 years. Real value of the investment after 2 years. Okay. So, subpart B, real value of the investment, that is, first of all, we have to get what the bank will be giving us after 2 years. Then we have to find its purchasing power, that is the real value of the investment. So, what is the amount that Jerome will be receiving after 2 years? And it is monthly interest rate calculation. So after 2 years, you have to remember, this is important. After 2 years means 24 months, because the rates that are given are monthly rate. Okay, so we have to take 6000 and 1 plus, it was 0.5. You see, it was 0.5. I can show you. It was 0.5. See? Okay. So 0.5 over 100 to the power of 24, because there are 24 months in 2 years. This is very important thing. You have to be careful about it. You cannot write 2 in this place. Okay, it is 24. And this is the amount that we will be getting after 24 months, yes, or 2 years. And what will be the real value of the investment? It will be getting divided by the inflation factor, which is 1 plus 0.1 divided by 100. Okay. So, this can be written as 6,000 times 1, this should also get multiplied to the raised to the power of 24. This should also get raised to the power of 24. Okay. So, this is 1 plus 0.5 over 100 divided by 1 plus 0.1 over 100 whole raised to the power of 24. Okay, because this is getting raised to the power of 24, this is also getting raised to the power of 24. Using the laws of indices, we can write this is, the whole thing is getting raised to the power of 24. Okay, and what is the value of this part, this whole part? This is equal to this 1 plus 0.5 over 100 divided by 1 plus 0.1 over 100 is this. Okay, so this is equal to 6,000 times 1.003996, and let us to the power of 24, of course, and let us find the real value of the investment after 2 years. Okay, so it is 6,000 times 1.003996 to the power of 24. 6602.66 I can take. Okay, 6602.66. So it is 6602.66. This is our answer. So what is the real value? The real value, I don't have any space to write over there, so I am giving the answer over here. I am making a box over here. This is the answer to the subpart B. So students, this brings us to the end of this session. Thank you for watching this video till the end. We'll be meeting very soon. Till then, bye.